Hello people, welcome back, and today we're going to be looking at the 2018 Chemistry Paper 1 Combined Higher from AQA. We're going to be looking at the answers, how to answer the questions in line with the mark scheme, so let's get on with it. Question number 1. This question is about electrolysis. A student investigates the mass of copper produced during electrolysis of copper chloride solution. So what do we have to know in advance? So first of all, let's have a look at this. This here is your copper chloride solution, and because there are copper ions in there, and there are also chlorine ions in there, any liquid that can conduct electricity or current, we call it an electrolyte. So this here is going to be our electrolyte. Now, second thing that we gotta take in mind is that this is the negative electrode, and a negative electrode is always called the cathode. The positive electrode is called the anode. The word inert means that it doesn't react. Now, the reason why the electrodes are made with carbon is because carbon is cheap, it conducts electricity, and it can withstand a very high temperature. Now, the reason why I'm making all these notes here is that so you understand where the answers are coming from, and it's little knowledge that is worth knowing before trying to answer a question, because it just makes things a lot easier. 1.1. Which gas is produced at the positive electrode, the anode? Now, normally when I encounter a question like this, I recommend my students to go through the process of elimination if they don't know what the answer is. What that means is that you're going to cross off the answers that are definitely not the answer. All right, they're definitely not correct. So even if you have to guess at the end, you have a better probability of guessing right, because at the moment we got a 25% chance of getting it right if we guess. But let's have a look. Now, we have to understand that it's gas that is produced at the positive electrode called the anode. Now, if it's being produced at the positive electrode, that means that whatever substance is being taken there is going to have to be a negative ion. Now, we know that the positive ions are always going to be metals except hydrogen. Hydrogen is the only non-metal that actually turns into a positive ion. Now, it will have to be a non-metal. Chlorine is a non-metal, hydrogen is a non-metal, oxygen is a non-metal, carbon dioxide, although it's made with two non-metals, is a compound. And a compound is never going to go to the positive electrode. Sometimes they might form a compound once the substance goes to the positive electrode, like in the case of electrolysis of aluminum, but not in this case. So, by this method of elimination, carbon dioxide is definitely not one of the answers. Now, even if we had to guess, we have a 33.33% chance of getting that right if we guess. Now, remember, because it says solution, this means that the copper chloride has been dissolved in water. Okay, now, having said that, what ions are we going to get? So from the copper chloride, we're going to get copper, we're going to get chlorine, and from the water, we are going to get H+, and we're going to get OH-. Now we got two sets of ions that are going to be competing to go to those electrodes. The two positives are going to compete, and the two negatives are also going to compete. Now only one of them can actually go into the electrode. So usually the most reactive of the ions will remain behind, and the least reactive is going to get sent out. Now immediately over here we can cross off copper. Copper is a positive, so it's not going to go to the positive electrode, and we can cross off hydrogen as well, because even though it's a non-metal, it's a positive ion and is not going to go to the positive electrode, because positive and positive reject each other. Now at this point we can also cross off hydrogen. Now even if we had to guess now, we have a 50-50 chance of getting the correct answer. Now this is a note that you might need to remember. Whenever there is a hydroxide and a halogen in a solution, the hydroxide is always going to remain in the solution, and the halogen, in this case chlorine, is the one that is going to be going to the electrode. There's going to be a competition between them two, but in this case it's going to be the chlorine, the one that is going to go to there. Sometimes you can get oxygen out of the OH, but this is not one of those cases. So your answer for question 1.1 would be chlorine. Question 1.2. Copper is produced at the negative electrode, the cathode. What does this tell you about the reactivity of copper? Tick one box. Now, once again, this is a multiple choice question, therefore I always recommend for you to cross off the answers that are definitely wrong and then try to search for the correct answer. Now, because this is question 1.2, it is still continuing with the electrolysis that we saw in question 1.1. It is all part of the same question. So, what ions do we used to get in that other question? We used to have the copper ions, and we also had chlorine ions, we also had hydrogen ions, and then we also have the OH ions. Now, remembering this, here's what we got to concentrate on. Copper here is competing with chlorine. Copper is not competing with chlorine because copper is positive and chlorine is negative. So this is not one of your answers. Plus, chlorine is not usually found in the reactivity series when that is taught at GCSE level. So that is definitely not an answer. Copper is more reactive than carbon. Well, not really. Carbon is above copper in the reactivity series, so this cannot be one of your answers as well. Copper is less reactive than oxygen. Again, this is not one of your options because oxygen is not found in the reactivity series at GCSE level, so you're never going to get a comparison between them. In addition, copper is a positive ion and oxygen is a negative ion, so you will never see that as well. Now, the only competition that you would see here is between copper, which has a positive, which is a positive ion, and a hydrogen, which again is the only exception, is the only non-metal that forms a positive ion. And we know that copper can be extracted by reacting with hydrogen. So if hydrogen displaces the copper, that means the copper is less reactive than hydrogen, and therefore your answer for question 1.2 would be copper. Table 1 shows the results of the students. So we got table 1 says the total mass of copper produced, and it's important that you get used to saying mass because you want to stop saying amount. Otherwise, in some questions you won't get the marks if you say amount. You have to say mass, or you have to say volume when it's a gas or a liquid. Okay, so we got the time in minutes, experiment 1, 2, and 3, and then you have your mean. So the first time, 0.6, 0.58, 0.62. When you add them all together and you divide it by 3, you get a mean of 60. Now the same thing has been done with this here and here. Now the question states, determine the mean mass of copper produced after 3 minutes. Now we can see that the 3 minutes has not been included on your table. So what you're going to do for this is that you are going to add minute 1 and minute 2 together, and that should give you the mean for minute number 3. Okay, so now let's move on to question 1.4. Calculate the mass of X of copper produced in experiment 2 after 5 minutes. Use the table 1 on the page. Now usually when you get this in bold is because they are actually expecting you to use any numbers that are on table 1. So let's have a look. They're asking us to find this number over here. Now we know that when they added these 3 together, it gave something, and then it was divided by 3, so we got 3.06. So let's have a look. Now, adding all those 3 together, it must give us a number and when that number was divided by 3, it gave an answer of 3.06. Okay, so we need to reverse our way back. Now, what is the opposite of doing a division? And that would be a multiplication. So if we're gonna reverse engineer what we did over here, what we're going to do is that we're gonna go for 3.06 times 3 instead of multiplying it, instead of dividing it, sorry. That will be 9.18. Okay, now know that this number would have been that number there. So now we know that this is no longer one triple question mark. This is actually 9.18. We have discovered the mystery there. Now, so what we're going to do now is that we're going to do that 9.18 and we're going to take away 3.01, and that's going to give us 6.17. So now we're going to take away 3.02, and that's going to give us 315, which means that x was 315, because what we did now is that we took away each one of those from the total, and whatever was left must be the x. So your answer for this question would be 3.15 milligrams. Okay, question 1.5. The copper chloride solution used in the investigation contained 300 grams per decimeter of solid copper chloride dissolved in 1 decimeter cube of water. The student used 50 centimeter cubes of copper chloride solution in each experiment. Calculate the mass of copper chloride used in the experiment. Okay, now this question tends to put off a lot of students, but it's fairly simple. Now, there is a few different ways of tackling this question, but I'm going to show you my way of doing it, which I believe is one of the easiest way of doing it. Okay, so what this is telling us is that the solution contains 300 grams per decimeter cube of solid copper chloride dissolved in 1 decimeter cube of water. All right, so what does this mean? Now, it says that if you have 1 decimeter cube of water, in there you will also have 300 grams of copper chloride. Okay, and once you have your solid copper chloride and you put it into the water, you make copper chloride solution. Now it says that the student used 50 centimeter cubes of copper chloride solution for each experiment. Calculate the mass of solid copper chloride used in each experiment. So in essence, they're trying to tell us if from all of this I only use 50 centimeter cubes, okay, how much of this would there be in just 50? Okay, so I have 1 decimeter cube, I add 300 grams of copper chloride, and then I mix it up, get it to dissolve, and then with a pipette or a measuring cylinder, I take out 50 centimeter cubes out of that. How much of that solid is going to be in that 50 centimeter cubes? Now, the way that I do this is pretty easy. Now, first of all, we need to realize that 1 decimeter cube is equal to 1,000 centimeter cubes. Okay, and this is the units that we're working on right now. Now my next step is to find out how many times can I fit 50 centimeter cubes into 1,000 centimeter cubes. So for that, we're going to do 20 times, which means that in 1,000 centimeter cubes I can get 50 centimeter cubes 20 times. Okay, so if I do 1,000 over 50, that's going to equal to 20. Okay, so what I do next is that because I can fit 50 in 1,000 20 times, I'm going to divide the 300 grams by 20. So each one of those parts that I get as a result is going to be in 50 centimeter cubes. So there you have it. Your answer would be 15 grams.
Right, so there you have it. A quick time revision. Like and subscribe, and I'll see you next time.